After the successful soft landing of Chandrayaan 3, ISRO is now launching country's maiden solar mission Aditya L1. Aditya L1 is being launched by PSLV C-57 rocket. There will be 7 payloads to study the sun, 4 will observe the light from the sun, and the remaining 3 will measure in situ parameters of the plasma and magnetic fields of the sun. According to the ISRO's website, the spacecraft will be placed in a low Earth orbit. Subsequently, the orbit will be made more elliptical and later the spacecraft will be launched towards the Lagrange point L1 by using onboard propulsion. As the spacecraft travels towards L1, it will exit the Earth's gravitational sphere of influence SOI, and after exiting from SOI, the cruise phase will start, and subsequently the spacecraft will be injected into a large halo orbit around L1. So the total travel time from launch to L1 would take 4 months for Aditya L1. It will be sending 1440 images per day to the ground station for analysis on reaching the intended orbit. This Lagrange point L1 is 1.5 million kilometers from the Earth in the direction of the Sun. So Aditya L1 will travel 1.5 million kilometers. The aim of this Aditya L1 mission is to understand the Sun's coronal heating and solar wind acceleration, solar wind distribution, coronal mass injection, etc. The Sun is a hot glowing ball of hydrogen and helium gases where continuous fusion reaction is going on. At the central region of the Sun, known as core, the temperature can reach as high as 15 million degrees Celsius. At this temperature, a process called nuclear fusion takes place in the core, which powers the Sun. The visible surface of the Sun, known as photosphere, is relatively cool and has a temperature of about 5500 degrees Celsius. Our Sun is about 4.5 billion years old and it is the nearest star and the largest object in our solar system. The Sun emits radiation, light, in nearly all wavelengths and along with various energetic particles and magnetic fields. But the atmosphere of the Earth as well as its magnetic field acts as a protective shield and blocks number of harmful wavelength radiations including particles and fields. So various radiations don't reach the Earth's surface and our instrument from the Earth cannot carry out studies of these radiations because they cannot be detected. So such studies can be carried out by making observations from outside the Earth atmosphere, and that is from space. So to understand how the solar wind particles and magnetic field from the Sun travels through the interplanetary space, measurements are to be performed from a point which is far away from the influence of the Earth's magnetic field. L1 mission with 7 payloads will study the in situ parameters of the plasma and the magnetic fields, the coronal mass injections. These coronal mass injections are similar to earthquakes on Earth. The 7 payloads are Visible Emission Line Coronagraph VELC, Solar Ultraviolet Imaging Telescopes SUIT, Solar Low Energy X-ray Spectrometer SOLEX. The payload is designed to measure the solar soft X-ray flux to study solar flares. Aditya Solar Wind Particle Experiment SPEX, Plasma Analyzer Package for Aditya Papa, Advanced Triaxial High Resolution Digital Magnetometers.